Okay, so for this, this is kind of like a car accelerates from rest to a speed of 60 meters per second. It then travels at a steady speed for 75 seconds, and then it decelerates to rest, covering a distance of 150 meters while decelerating. First question it asks us there is to find the time spent decelerating. Now, there's a couple of ways you could go about this. First off, just maybe to highlight what we do know. We're definitely, if you look on the question, we're definitely going to be doing the total distance covered. So that would, when you see that kind of question, you're definitely thinking a speed time graph, because the area under a speed time graph is the total distance covered. The next thing you're looking there is for the average speed over the entire journey is the total distance covered divided by the total time. So where to start with this one here? Well, first off, if we find the time spent decelerating. So the time spent decelerating, we know that it goes from a speed of that to over a distance of that, and we're asked to find, we know that the final velocity then would also be 0. So for this section we know u is equal to 60 meters per second, s is 150 meters, and the final velocity, because it decelerates to rest, which is a very important word there, so that tells us that the final velocity is also 0 meters per second. Again, you should be very familiar with the 3 equations of motion that we use. I'll just fill them in here again. And you want to pick out the one that you're going to use for this. And they're kind of a bit messed up here, but you can still see them. It's this one here, the second one. V squared is equal to u squared plus 2as. Or is that the one we'd use? Time is what we're looking for. We need to find, in this one here, we need to find the acceleration first. So we have to do this in 2 stages. So I'll do that quickly. V squared is equal to u squared plus 2as. V squared is 0 is equal to u squared, which is 60 squared, plus 2as times 150 meters. So 60 squared, 0 is equal to 60 squared. 60 squared is 3,600, plus 2 times that will be 2 times 150 will be 300a. So 300a will be equal to, if I well, I'll write it like that, minus 3,600 be equal to 300a. Divide both sides by 300 and we get a is equal to minus 3,600 divided by 300. They cancel. 3 into that goes 12. It's actually minus 12 meters per second squared. Now we've got the acceleration. We can use v is equal to u plus at to find the time. So if v is equal to u plus at, we know that v is 0, u is 60, and it's minus 12t. Bring that over, we get 12t is equal to 60, t is equal to 5 seconds. We now have enough information to draw our speed time graph. We've got the time spent decelerating is 5 seconds. Now, to get going on that, I'll just make a little bit of room here. And we'll start off with the time axis. Now the time axis goes along the x-axis here. The distance or the speed is going to be going along this axis here, and it's about to fill in our distances now. If you have graph paper, it would look better for this question. So the first thing is it accelerates at 3 meters per second to 60 meters per. It accelerates at 3 meters per second to a speed of 60 meters per second. So if I mark in 60 meters per second here on our y-axis. Now we know it accelerates at a rate of 3 meters per second, so it accelerates up to there. The next part is we know that it goes for 75 seconds at a constant velocity, and then it decelerates over a time of 10 seconds. So I'll fill in my times that we know here already. I know that the time from here to here is 75 seconds. I know the time from here to here, we worked it out in the first part, is 10 seconds. I still don't have this time here, so I might as well just work it out quickly as well. So we know for this part here, we know that it has acceleration of that. I'll do it in this one here. We know the acceleration is that it goes to a final velocity of that, and we can use this here to work out its time, the time it took to get to that velocity. V is equal to 60 meters per second, so it's V is equal to U plus AT. V is equal to 60 meters per second. A is equal to 3 meters per second squared. U is equal to 0. We're looking for T, so this is the one we use. 60 is equal to 0 plus 3T. Time is equal to 3 divided by 60 is 20 seconds. So I know this here is 20 seconds. Now, if we want to find the total distance covered, there's a number of ways of doing it. If we have the speed time graph, so that's the time, that's the speed or velocity time graph, speed or velocity we call it, we could just get the area underneath the graph. Now I know this is already 100, we're given it, 150 meters. The area of this bit is 75 times 60. Which I'll work out now in a second. So we've got 75 times 60. So this distance here will be 6 noughts are nothing, 6 fives are 30, carry the 3, 4,500 meters. That's in part 2. In this section here, we've got half the base by the perpendicular height to get the area of this triangle here. So it's a half, 20, multiplied by the perpendicular height, which is 60, which is equal to 600 meters. So the total distance, you could have used the equations for this as well, I'm just doing it this way. The total distance for the first part, second part and third part, which is equal to 600 plus 4,500 plus 150. So adding these together, we get 750 plus that would be 5,250 meters. Now we know the total time, and we know the total distance. The last part is the average speed. You must remember that if we're getting average speed, so just number this part here now. Part 2 is, or 3, is the average speed. It's total distance over the total time, which in this case is 5,250 divided by the total time, which is 20 plus 10 is 30 plus that, which is 105, which is equal to, and I'll just do that quickly, 5,250 divided by 105 is equal to 50 meters per second exactly. So our answer here for this third part is 50 meters per second.